Hi everyone, I'm Adnan Hodzic or Hodzic, and I've been with ING for over 5 years, where I work as a tech lead for a data analytics platform, GCP or public cloud area. So this area consists of 4 different teams, building a scalable platform for ING tenants and their projects. As part of this area, we create solutions for data, AI, ML on Google Cloud. So in this talk, I'll go over how DAP, or Data Analytics Platform, got to where we are in our Google Cloud migration journey, what we're working on, lessons learned, and where are we going next. So our story takes place at ING. ING is global and one of the world's biggest banks, definitely the biggest bank in Netherlands. It has over 60,000 employees, one-fourth working in tech, and ultimately serving around 38 million customers in over 40 countries. Before I get into what we do as part of our area, I would first like for everyone to understand what is DAP, or Data Analytics Platform, what is the purpose. So DAP is a place where we enable our colleagues to do model development, model execution, data analysis, dashboarding, and reporting. So let's take a look how this looks like in practice. Let's say business has an idea to develop an instant loan calculator. For that, they need to develop a data model. Data scientist and data engineer will come to DAP to do their job. Data engineer will transform the data required and build a data pipeline, and data scientists will develop the model and train it on this data. So at this point, this is all an experiment, and why we call it an exploration. And once the experiment has been successful and model has been validated, we'll help our data scientists bring it closer to execution. During this phase, a DevOps engineer connects the model to the application that will be consuming it. In this case, this is retail banking, and this is how you will see it if you're an ING user as part of your app. Last 2 journeys are data analysis, dashboarding, and reporting. Business user, data analysts come to DAP to build dashboards, do their analysis, and create reports. So now that you have an understanding of what DAP is, it's worth mentioning that DAP consists of multiple teams and projects. For example, teams like machine learning platform. And we rely on various software technologies like Spark and Kubernetes. Fun fact, DAP is running on one of the biggest on-premise Kubernetes clusters in ING. And the result of all of these different components and teams can be seen as part of the self-service portal, dap.ing.net, which looks like this. And among other options, once you log in, you have an option to create a project. And here you give a project a name, define its cost, purpose. And while Google Cloud is also an option here, I'll select to create it as part of ING Private Cloud. Once this is done, you can see all of the available applications and options for that project. But since this is a new project and will be empty, and to give you even more ideas of what's possible, I'm now switched to another existing project, which has a completely different use case, and as such has completely different applications and tools. So here we see an Airflow instance with 3 jobs and an error. If I click on it, I'll be redirected to Airflow interface, and I can see what's going on. So now that you have an idea what DAP is, and everything we saw so far was revolving around workloads running on ING Private Cloud, let's talk about the elephant in the room, and that ING is using Google Cloud. So story time. Last year I gave Kubernetes resistance is futile talk at KubeCon in Amsterdam, and after the talk numerous people lined up with various questions. And one of these individuals approached me and said, since my work title said I was part of a public cloud team, if we were really doing public cloud related stuff in ING. To which I said, yeah. After which he bursted into laughter, thinking I'm joking. And when he saw I was serious, he started to ask me actual public cloud related questions. And this stuck with me as it made me realize how wider tech community thought ING will never go down this path due to regulatory, risk, security, and compliance issues. There was even a problem of public perception. Nowadays, all of our stuff is in the cloud. Should our money also be in the cloud? ING being such a big company, to this day, I'll end up in meetings where colleagues from different departments or different countries have no idea we're using GCP. Hence, in this context, I would say public or Google Cloud resistance is futile. And I previously mentioned ING has its own extensive on-premise setup with multiple data centers. So why even consider moving to Google Cloud? So let me lead you through our journey and why, in my opinion, this migration was inevitable. So folks like to think how everything on-premise is free, which is just wrong. It could even end up costing you more because for all the potential use cases, you have to pay for everything up front. You still have to hire engineers to maintain it all. Things like COVID can happen just when you need to migrate a data center from one country to another, which can make things complicated to say the least. This can also lead to an inability to get certain hardware due to chip shortages. And just because you have keys to a data center doesn't make it more necessarily secure, because you could even argue that Google engineers can find certain zero-day exploits or security vulnerabilities faster, and then your engineers can simply apply them by using one of the built-in services. And also, just because you're migrating to public cloud doesn't mean you need to leave everything behind in terms of your on-premise setup. There will be workloads which will always run on-premise, and that's fine. And that's why hybrid cloud might be the best architecture to go for, as it offers you the best of the both worlds. And then around this time, DAP started to get requests for building a solution that would require clusters that would consist of 10, 15,000 nodes per cluster. There would be a couple of clusters per environment, which means the project could easily go to like 100,000 nodes per project. And what made it even worse is that these clusters would do heavy calculations for like 45 minutes on a daily basis, meaning they would be in idle state for most of the time, consuming an enormous amount of electricity and costing a fortune. And what Google Cloud allowed us to do is spin up ephemeral clusters when needed, and then they would be automatically shut down and deleted after it was all done, as they never even existed. And I'm absolutely confident when I say this, there's no on-premise setup in this audience that can satisfy this criteria. And that's how DAP GCP was born, where DAP would host data analytics-related tenants and projects. These projects were of enormous value to ING and would not fit being hosted anywhere else, or would not have capabilities and services provided by GCP. Today, DAP GCP area consists of 4 different teams, but it all started with an engineering team whose mission was to do everything it takes to bring ING tenants and their projects to production on Google Cloud. In ING, we have principles of separation of responsibility. So there isn't a single person that can push their changes and somehow they end up in production. This just doesn't happen. Regardless of environment, every pull request follows 4I's principle. So it needs to be approved by 2 different people. Depending on the environment, a change might even need to be created up front for a pipeline to succeed. So quite some changes needed to be done for code in tenants repository as part of separate part of ING to be picked up by us and deployed to a GCP resource under our control. And to illustrate this, although it might not look like it, I've created a simplified DAP GCP architecture diagram in which we showcase how tenant X code would be deployed to tenant X GCP service, data prod cluster in this case. Please note, besides non-prod and prod environments, we also have execution and exploration environments. So exploration environments are used to explore for development purposes, and they can include users, like this data scientist here accessing the Jupyter notebook. Execution environments, on the other hand, are for running non-interactive pipelines to train the model with the goal of generating production quality data analysis. Everything in these environments is completely automated and defined as code without any user interaction. And in this process, please focus on the orange boxes from step 1 to 3, where tenant will push changes in their repo, pipeline will be triggered, and ultimately a service will be created in GCP. Data will be coming in from the data plane concept, where data is specifically mapped for that environment. And you cannot, for example, mix prod data with the test environment. And let's see how this looks like as part of some of the data flows. So this is an example of tenant X data flow, where we have a couple of ING data lakes. Data is copied and automatically synced to the designated buckets. And in this case, it's going to be consumed as part of the data prod cluster. And if there's any work coming out, it can still be synced back to ING data lakes. And another flow with tenant Y, there's a lot more ING on-premise data lakes. Again, data is copied and synced, and here it will be consumed by data flow, and it will ultimately end up in BigQuery. What's interesting about this use case is there's also on-prem Kafka direct connection with the on-prem Kafka system. In case of a disaster, because all of our resources are ephemeral nature and such can be easily re-provisioned if something goes wrong, we're currently working on disaster recovery for our data layer. So if the whole Netherlands region or a country disappeared and stopped working, all of our data would be available and served from a region in Germany. So let's see what I explained in the architecture diagram and how simple it is for data scientists to deploy their own Dataproc cluster. So this is, for example, they can define the TTL, time to live. If cluster is in active state for 1 hour, in this case, it will be automatically deleted. Region can be selected. You can specify the Chekhov scans to do code analysis after you hit run. Please note, we don't expect nor do we want our tenants to know Terraform, but we allow them to specify some cluster properties if they simply fill out few variable values as part of their TFRs file. So for example, which Dataproc cluster they want to use, worker instances, pip packages, or some specific cluster properties. Once they're happy with these and other changes, and they're simply pushed, all they need to do is create a Git tag, give it a name, and specify the branch on which the changes will be based on. And tag will be automatically picked up by one of our pipelines. In a matter of minutes, Terraform will kick off, and automatically your cluster will be created in just under 9 minutes in this case. Results is then you can see a new Dataproc cluster with my Git tag name. And if I go to the web interface of the same cluster, I see Jupyter Lab, and I, as a data scientist, will be ready and go do my job. Team will also help do an onboarding process and provide help with design and architecture. Besides project creation, team will create networks and create firewalls, because this is a process of its own in a highly regulated environment like ING. And team is adherent to principles of infrastructure as code. We have a common Terraform module repository. So as it was also shown in the architecture diagram, it has a lot of TF stacks and modules. If your service is not part of the code yet, team will create it for you. Or you as a tenant can also contribute. ING, being a bank, has a rigorous security and compliance criteria that need to be satisfied. If you're not adhering to this, it's the end for your project, and as such, won't be able to exist. To satisfy this criteria, on-premise setup, for every user that's part of the system or has access to data, this is evidence to Excel. However, GCP being an ever-evolving landscape and service accounts being created and deleted on a daily basis, and roles and permissions being attached and detached also on the same basis, this was like an impossible task to get control all over this data, because even by the time if you fetched it manually, by the time you wrote the report, you were already out of date. And being someone who's slightly allergic of Excel, I had an idea. Since all of the information in GCP can be fetched using API calls and Excel sheets can be written using Python, why just not create an automated tool that does all of this automatically for you? So what you're looking at here is that same report, except prettier, written automatically with Python and data available in GCP. So you can now see all of the GCP projects, all of the service accounts, if it has any keys attached to them or not, who's the owner, DApp, tenant, or someone else. If there's a service account that wasn't created with code, you'll see something like error, unable to determine. So you should probably look into what's happening here. You can also see if there are any additional roles that are in non-compliant list, if a service account is run as part of a pipeline or vault. And finally, you'll also see a comment, because these reports can be generated by risk, for example, and by just simply running a pipeline, and each pipeline can be used for audit purposes later on. Team also has monitoring alerting system based on templates, so new projects are easy to onboard. We have capabilities to be alerted on various things, including IAM, what I just showed in the previous example. We even have drift detection, so if the changes in your GCP console web interface don't reflect what we have in code, we will be alerted there's a drift, and someone will take a look into what's happening there. The team also offers support to all of our tenants to help them with any of their needs. And what engineering team was doing on this point was creating projects for tenants and use cases with special requirements and needs, if you will. And you can think of it, until this point, we were creating custom-made cars. And what we wanted to have is an assembly line with all of the cars more or less looking pretty much the same. As instead of having just few projects, DApp has an ambition to have thousands of them. And that's how that GCP platform was born. Engineering team being responsible for so many things meant the more projects you want, you need to hire more people, which just doesn't scale. So, only way to fix all mentioned problems is create a platform, just as it is on premise, with self-service portal, where we allow user to create GCP projects, for example, with access to Vertex AI, and abstracting them completely for all the underlying complexity that's happening under the hood to create this stuff. While DApp GCP platform is still not part of the DApp self-service portal yet, I'll give you a sneak peek what this looks like today when Trigger is part of one of our pipelines. So give a project a name, define the members or groups that will have access to it. After you hit run, result is a new GCP project, which it has its own instance of Vertex AI Workbench with Jupyter Notebook. Once you click on it, it allows a user to easily experiment, for example, with Gen AI. So as part of it, we can ask Gemini questions, and turns out Gemini knows ING pretty well. And what you just saw is a spec of options the final version will have, as it's only currently it's only oriented towards Vertex AI and Gen AI use cases. Our tenants were requesting BI, and while in ING we have dozens of such services, Looker being native to GCP was an obvious choice, and that's how that GCP Looker was born. Since we realized all of our tenants would require BI capabilities, why not just create a managed platform? So besides getting your project as part of the self-service portal, you'll also get BI integrated with it. And while from my point of view, there's so much left to do, and things are constantly changing, and I'm on constant lookup to see what's coming next, doing this talk was a great reflection point as it made me look back to how much was done until this point. So in terms of a time lapse, how long did it take us to build all this? From creating first projects to being in production took us just over 2 years. So let that sink in. And in the end, I look forward to see where we are in the next 2 years. Thank you. And just last thing I want to say, since there isn't a lot of time left for questions, I'll be around for anyone who wants to ask me anything. There's an ING booth right there, 226, and we can talk about anything, or even about joining us, because we are hiring. And yeah, if I'm not there, just leave your question, but I think we have time for a question or two now. So ask me anything.
Any questions? I can come up microphone.
Hello. Being in a bank, in my professional history, I have always thought that the data cannot go in public cloud, right? So I've seen for the first time that you have implemented GCP, but as you have shown that you also have the on-prem environment to keep the data. Is that your final architecture design, or because you're still migrating, that's why it exists?
Yeah, so as I said, everything keeps changing. So that's the data plane concept, right? But we already are working on the data plane V2, besides getting data from Kafka, right? Or data coming in from ING data lakes. We're now also working, for example, with data coming in directly from public, which is a very scary thing for a bank to do, but we're working on it. But this is where all of our data is. If any of the data as part of the data plane is tampered with, or even a service account accesses a certain bucket that they shouldn't access, we get alerts. So it's all like, we have alerting for all of it. Nothing escapes, none of your actions. And that's how we currently deal with that. But yeah, it's ongoing work in progress. I cannot hear.
Hello. Are you going to fully migrate to Google Cloud? Or?
That's an excellent question. We were talking about that before. Yes, we will so far, but there will be some workloads which will always remain on premise, and that's fine. But it's interesting you say that, because that was our initial thought. Let's move everything immediately. Just we're going to the cloud. And some people were like, yeah, but we're good the way things are. And now our new strategy is like, if you're happy when on premise, just stay there, right? But there's a lot of use cases with people that just want to go to the cloud. Like, it's beyond, we really have a lot of building to do. But that would be my suggestion. So everything will end up in the cloud. But if you want to stay on premise, yeah, you're free to stay there.
Still have to maintain the data warehouse at one place, right? Which is in
Yeah, yeah. No, but that's another thing that we were talking about, part of design. This is something we still haven't made a final decision on. Like, is it going to be just one single data warehouse, or is it going to be per project? So this is something that, yeah, we haven't made a final decision. So what we do currently, and I think that helps, especially for different teams, we make designs. Like, this is what we're planning to do. Review it. If you didn't review it, then don't say anything after it's being implemented. It's over. But yeah, that's my proposition. Just talk about it because things change, and even the whole syncing, that's also now being revamped, if you will. So a lot of changes coming in. Maybe you'll hear about it on next talk in a couple of years. We'll see. One way to find out. Another one? Okay.
We had a question for staying on premise.
I cannot hear him.
No? Yes? Okay. Hello?
Yep.
Okay. So you were saying that if you're happy with staying on premise, you'll stay from premise. What would be the pros for staying on premise for you at ING instead of going completely to Google Cloud?
What would be the cost?
The pros, benefits.
On staying on premise?
Yeah.
In my opinion, none. Like, it's just like, people don't like change. So it's like, oh, I want to continue being there. But I don't see any pros because you're missing out a lot of things, what's happening with cloud, especially with Gen AI and what Google is offering you. So I don't see any pros. But I am also biased, so.
That was my thought exactly too.
Yeah. And do we have time for another question? There's another question there. No? I'll be around. All right. Thank you all.